counts, and just a lightly hopped wort of 12 plate or 1048 gravity. So again, there's kind of the growth curve from the research of what was seen with, I think it's about 4 or 5 strains. So primary fermentation. I see primary fermentation in 2 ways. Basically a clean fermentation or the sour primary fermentation. So clean fermentation, we're talking about a Brett primary fermented beer. It's not using any sour organisms or sour mashing. Fermentation takes between 2 weeks and 1 month. It's really going to be strain dependent. So some strains, I've seen strains that take longer than 3 months, and I've seen other ones that take 7 days. So you kind of want to play around with that. Personally, I'm a big fan of actually using a couple of Brettanomyces at once. I think it's better for flavor stability over a long period of time, and I think it's better for getting more true kind of attenuation out of the Brettanomyces yeast. I'm not doing any fermentations that have less than 2 strains in them, and generally more around 3 to 4. So little to no perceived tartness, as I said. In an anaerobic fermentation where you've got an anaerobic environment with very little oxygen except from the very beginning, you're not going to have much acetic acid produced because there's no oxygen for the acetic acid to be produced. Over a long period of time, as you have a little bit of influence with oxygen, you might get a pickup of a slight tartness from minimal acetic acid, but overall, if you're not heavy oxygenating at knockout, you're not going to have that. So then the other form of a Brett primary fermentation is the sour. So this is where you're either doing a sour mash, you're maybe using lacto or some sort of souring organisms in the primary and with time while it's aging. Acidulated malt's another option. I know a brewer's using 10 to 12%, some 5 to 6. It's kind of all in the range of what that pH, what the flavor contribution you want out of that. It certainly appears to improve attenuation, and I think I've got a graph after this that kind of shows a little bit more about that. And then fermentation time, still about 10 days to 1 month, and again, like everything, it's strain dependent. But a lot of people associate Brett beers with being tart or sour beers. I think it's one thing, certainly to realize as you're buying, say, beer from other commercial brewers and stuff, just because it says Brett, it does not mean it's a sour beer, because Brett is not a souring organism. But all the same, even when people smell that beer, they generally associate it with being a sour and tart beer, so it can be complementary. So primary fermentation, I'm knocking out at 60 degrees Fahrenheit, so about 20 degrees C. So going from the kettle into the fermenter, really try and hit 68 degrees Fahrenheit, then pitching the yeast, and I'm letting fermentation ramp up to 72 degrees Fahrenheit. I prefer to keep the fermentation around about 70 degrees, and that seems to get me a stable, sustained fermentation. And at this point, all of our Brett fermentations are finishing at under 10 days for the fermentation, and then letting them condition for a couple of weeks longer. It seems to be a really nice temperature. It doesn't mean you couldn't let it ramp up maybe a little bit higher, as some other, some people do with their saisons, getting 80, 90 degrees. I just think that's a little high for your higher alcohols that are produced, the more subtle, kind of fruitier characteristics from the bread. I heavily oxygenate at knockout, 12 to 15 parts per million or so. It's kind of hard to measure that, but it just kind of go off look and everything, trying to get a good amount of oxygen in. The increase in O2 increases acetic acid production. The amount of acetic acid that's produced just from that initial oxygenating, it's so little, but it's just a subtle amount to get you kind of a sweet tartness. Because acetic acid, as a light acid, it's a very soft, really complementary acid. It's when it gets higher that you get, the acetone and the vinegar type aromas. But I mean, it's so far gone from an infection, and it's not what Brett's going to create. So I find it complementary. Some beers you might not, but you always want to at least oxygenate. It's a yeast. Physiologically, it needs the oxygen to start producing lipids, start producing its cells. So definitely oxygenate, or just like with Saccharomyces, it'd be the same as if you didn't oxygenate with that. You're going to have, a poor fermentation. You're going to get off flavors, which I don't know what's not an off flavor in a Brett beer, but I like it. So pitching rate. Through the research, actually, we looked at 4 different pitching rates. Half, full, twice as much, 3 times as much, and there really was nothing to draw a straight conclusion from. Just in my personal opinion, I go with the standard rule of thumb that you would use with an ale. So, 1 million cells per meal per degree Plato. That's what we're using right now. It seems to work great. I like the way the fermentations are finishing. I like the way the flavor is, and that's what I would suggest is pitching it the way you would in the ale yeast. And in the beers, most of the beers that we're brewing are 14 degrees Plato, so 1056, and the beer's attenuating down to about 2.5 Plato in 7 to 10 days. As I said, I'm using 3 to 4 Brett strains, and I think that ups the complexity in the strains. I think sometimes a single Brettanomyces strain on its own is not as complex as some of its brothers, the Saccharomyces strains. And so by using 3, I'm getting more complexity out of the gates, and I'm also getting more complexity in the long run. Because Bretts tend to have periods where their flavors are better within a single strain, and so I see that I'm kind of overlapping that by having a couple of Bretts in there. So faster fermentations when repitching, so pull a little bit off, reuse it, and greater ability to ferment high gravity beers. We had a Baltic Porter, it's actually about 22.5 Plato, attenuate down to 4 Plato in 10 days. Super dry, super fast. I mean, that's like Saccharomyces. And it's nice, the character is so different, but really complementary. And then the other is, I know this is a little bit harder because this takes like you and like 8 buddies, but an oak barrel primary fermentation. A lot of stuff has shown that a little bit of oxygen continuing, and I mean like a really little bit of oxygen, not enough to even be producing much acetic acid that's noticeable, is beneficial in stimulating fermentation. And this is actually a photo of our very first batch that we did on January 10th. Just knocked out straight from the kettle into the barrels, filled them up all the way, and then pitched. These were single strains of Brett, but like 2 per barrel, so there's 3 different Bretts. And that's kind of them on, I think that's 2 days in, maybe not quite even 48 hours, and it's just now kind of fermenting over. Brett's kind of interesting. It doesn't produce a really big krausen. It tends to actually be a bottom fermenter. Some kind of sits along the top a little bit. It's a powdery yeast, so it won't produce kind of that nice like silk kind of layer exactly. Some of them do, but for the most part they don't. But you don't get a crazy active blow-off or blow-over with the Brettanomyces. But a word of warning is it can have an heavy H2S aroma in the barrels if they're not able to breathe. And the benefits of pre-souring wort. So this is looking at that kind of the sour beer, the sour Brett primary fermentation. Whether it's through acidulated malt, a sour mash, or a sour wort, pre-souring the wort with lactic acid leads to better attenuation with a greater range of Brettanomyces strains. Increases the flavor compounds, can add depth and complexity. Both ethyl acetate and ethyl lactate were increased. Go figure, you got lactic acid, it's going to produce ethyl lactate. But you want to be careful because in the beginning you're going to get a buttery flavor, and it's different than diacetyl, though it's not as slick, but it's kind of a buttery, cheesy flavor. That will mellow out and kind of go away. Esters like ethyl caproate and ethyl caprylate. So these are the 2 that I associate with the pineapple flavor. I think that's important. Everyone talks about like where these flavors come from. That's really the 2 compounds that I associate with that. These dropped, or at least they appear to drop within the first 35 days when you had a higher souring content. So you're going to get maybe a little bit less of that characteristic, but you're going to have overall, general, more compounds and more flavor characteristics. So conclusion, yeah. Lactic acid appears to increase attenuation. Sour mash or some acidulated malt is beneficial. Too much acids lowers the pineapple and fruits. In our first commercial batch, that was the one that was in the barrels, I dropped the pH to 4.5 to start primary. It finished in under 3 weeks. In our most recent sour wort batch, which was at about 3.05 pH, I have no clue how I got that low, went from 10 Plato to 1.5 Plato in 9 days. And it took 2.5 days, about 2.5 days for the fermentation to take off. So it was a slow takeoff to the fermentation, but then afterward just brought it really dry. A word of caution if making sour wort. First thing is, if you're going to knock out, if you're going to do a no boil, or maybe you're going to boil but you're going to knock out, drop the pH to 4.5 before knocking out. This will help reduce any compounds that could grow in it since you're not actually pitching the yeast. Knock out at about 120 degrees Fahrenheit, and try and sustain that temperature around 100 degrees for a few days. Do not oxygenate. If you're going to oxygenate, you're going to increase the ability for enteric bacteria and things like that to grow, which is going to give you butyric acid and other compounds that you don't want. You're looking for a clean souring beer. And purge as much CO through the wort as possible. So I know this is a bit harder if you have, if you're using glass carboy or anything like that. I guess this is talking about more if you have like a small sort of like fermenter or something like that. So purge CO3 to it till you can really get the CO2 coming off and come through your blow up. And the other is pitchiculture. If you can get some lactose, so there's something in there to get it going, and then the malt, also what's on the malt will take off. And you can reboil after you kill the lactose. So if you're afraid of it taking off and getting too sour, you can bring it back into the kettle and boil it. We did it with 10 barrels of beer just recently. No change in flavor stability at all. And this is just kind of a graph from the research that shows the impact of free souring on wort. So you can see from lactic acid, milligrams per liter parts per million of 0 to 3,000, you can see just kind of a general increase in the overall attenuation of the beers. Hybrid mixed fermentations. This is the same idea as, I know people have talked about this with Saison mixed fermentation, so I know sometimes with the DuPont strain, with some of these strains that you get a lag, you might get half fermentation going, and then all of a sudden just pouders out for 2 weeks. People see the same thing sometimes with Brettanomyces. And so this is kind of pitching Brettanomyces and Saccharomyces at the same time. So you're getting some attenuation from some and some flavor contribution from the other. And in my opinion, I kind of see this as the best of both worlds. So you can have the Saccharomyces primary for a few days, and then pitch Brettanomyces while the active fermentation is still going. This is similar to kind of like a secondary fermentation. You can also underpitch in primary with Saccharomyces strain, so where you actually stress your Saccharomyces out a little bit to where it stops fermenting, and then transfer maybe to another tank, so off that yeast, and do a large pitch of Brettanomyces to finish out that fermentation. Brettanomyces is a really high alcohol tolerance. I've seen as high as 12%. I would not be surprised if it would ferment or continue to develop flavor in a beer as high as 15 to 18%. Another idea, Brettanomyces yeast pitched first for the primary, and after pitch Saccharomyces to finish out attenuation and fermentation is going to improve mouthfeel as well. And then just a straight mixed fermentation, so pitch both Brett and Saccharomyces at the same time, let each one do its thing. You're going to get a relatively clean Brett character, and it's going to develop over a few weeks. So this can sometimes take a little bit longer if doing it that way, but it's nice that it's already there. You're letting them each kind of do their thing. Once fermentation is complete, it's good to rack the beer off the yeast and to mature the beer with only the yeast on solution. Generally, this is going to be Brett, and that Brett's going to continue to develop its characteristics. Secondary fermentations. These are the most popular Brettanomyces fermentations. They add complexity and new direction to the beer. Some factors you want to consider is assess what changes are likely to take place and how it's going to affect the beer. Residual sugars are important. There's research that's shown that maltose, maltotriose, some of those sugars that are still left that give the mouthfeel, that give the body to the beer while still being a dry beer, are really going to be eaten. So you've got it coming down to like 1.03, 5 grams residual sugar down to less than a gram. So you want to think about the body, the makeup of the beer when you brew it. We're going to get to that in a second here. So it's just kind of important to have some extra dextrins in the beer, maybe especially in malts or adjuncts. The extraction of phenols and hydroxycinnamic acids. I think one of the beers that people add Brett to the most are Saisons. It's nice. We think of them, the beers of Wallonia, some of these classic, like wild characteristics that they have. The thing you want to be careful with is that the Saison yeast strains, they do produce some of the phenolics that we talked about earlier. Brett then has the ability to take those phenolics and produce them into the ethyl phenolic, and that's going to produce maybe some of your medicinal, some of your characteristics that are a little bit stronger, and some people don't quite like as much. So the hydroxycinnamic acid is present in the cell walls, the malleable layer in the husk. A ferulic acid rest will create the precursors, as well as excessive handling of the malt and the mash. And you want to be careful with over-sparging and sparging too hot. Some will boil off in the mash, but some won't.